Hello friends, welcome to my channel. In this video we will discuss SSC JE 2020 solution, exam date 11/12/2020, shift 1. This is part 4 of this video series. Technical part we will cover. In part 3 already we discussed up to question number 140. Question number 140 onwards we will discuss in this part 4. So first question, when solidification starts, iron will appear in dash form. So from liquid state to solid state. 1539 degrees Celsius melting point. Then if you reduce its temperature, first you will get delta iron, then you will get delta iron BCC structure, then you will get gamma iron FCC structure, then alpha iron BCC structure. So when solidification starts, iron will appear in dash form, delta iron for BCC. C is your correct answer. Next question, toggle mechanism is not used. Not used. So from option we will take switches we are using, toggle mechanism, then stone crossing also we are using, gear coating we are not using. So C is your correct answer. Embossing we are using. So gear coating we are not using. Toggle mechanism. C is your correct answer. Next question. Air is compressed isentropically in a compressor from 1 bar to 5 bar, assuming gamma equal to 1.4 for air and clearance volume is 5% of swept volume. The volumetric efficiency of the compressor is how much? So volumetric efficiency we have to calculate. 5 to the power 0.714 equal to 3.157. So volumetric efficiency of compressor we have to calculate. So data given, air compressor P1 equal to 1 bar, then compressed to P2 5 bar, gamma equal to 1.4, air given, VC equal to 5% of stroke volume Vs. 5% means 0.05 of Vs. Volumetric efficiency we have to calculate. Clearance factor C equal to Vc by Vs. How much you will get? Vc by Vs 0.05. Then one more thing given, 5 to the power 0.714 equal to 3.157. Pressure ratio, how much you will get? P2 by P1 5 by 1 5. Volumetric efficiency formula 1 plus C minus C to the power C into P2 by P1 to the power 1 by n. So how much you will get? 1 by 1.4 equal to, or 1 by n equal to 0.714. So 1 plus C is how much? 0.05 minus 0.05 into P2 by P already given this value. So 3.157. How much you will get? 3.157. 5 into 3, around 15 you will get. 0.157. So 1.05 minus 0.157. How much you will get? 15 means around 85 you will get. So from option we will check. It's more than 85. Around 89 you will get. D is your correct answer. Little bit time taking. Around 1.5 minutes it will take. The next question, pick the correct order of various turbines with respect to specific speed. Pelton turbine, high head, low speed. Kaplan turbine, low head, high speed. Francis, medium head, medium speed. So correct order with respect to specific speed. Kaplan is highest, then Francis, then Pelton. C is your correct answer. Question is from RSC. Time taking question. It's better to leave this type of question because it will take more than 2 minutes. Question is, an air refrigeration system works on Bell column cycle. It draws air at the rate of 1 kg per second from the cold chamber at 1 bar and 5 degrees Celsius. Air is compressed to 7 bar and then it's cooled to 25 degrees Celsius before sending it to expansion cylinder. Given gamma value given, Cp value given, then 7 to the power 0.286 also given. Refrigerating effect for this system in ton per hour is how much? RE value you have to calculate. Bell column cycle. Only I am giving the formulas. If you want to calculate, you can calculate, no issue. M dot value given, mass flow rate 1 kg per second. Then P1 value given 1 bar. P2 value is 7 bar. T1 given 5 degrees, so 273 plus 5, 278 Kelvin. T2 value given 25 degrees Celsius, 273 plus 25, 298 Kelvin. Gamma value given 1.4, Cp value given 7 to the power 0.286 equal to 1.745 given. RE value we have to calculate. Refrigerating effect. Pressure ratio Rp P2 by P1 equal to 7. Coefficient of performance of Bell column cycle. First you have to this formula 1 by Rp to the power gamma minus 1 by gamma minus 1 1 by 7 to the power 1.4 minus 1 is 0.4 divided by 1.4 minus 1, you will get 1.342. Then you have to calculate RE value. 1 point, and we know COP equal to refrigerating effect divided by water. So refrigerating effect 1.342 into QR minus QE. QR and QE value you have to calculate from T value. You have to use T2 by T1 equal to P2 by P1 whole to the power gamma minus 1 by gamma. From here you can calculate T2 value. This one T3. I will draw that cycle, then you will understand. Constant pressure, 1 to 2, then 2 to 3 constant pressure, 4 to 1 also constant pressure. 1 to 2 is isentropic, 3 to 4 also isentropic. So you can calculate T2 value. It will come around 485.11 degree Kelvin. You can reach it. And like that T4 also you can calculate. Whole to the power gamma minus 1 by gamma into T3. It will come around 170.81 degree Kelvin. Then QR you can calculate how much it will come. 1 into 1.005 mcp dt. 485.11 minus 298. QE also you can calculate. Cp 1.005 into dt is how much? 278 minus you will get 107.72. Then refrigerating effect into 188, 107. Kilojoule per second. Then I will erase this one. 1 TR 3.5 kilowatt. So 107.789 kilowatt divided by 3.5 TR. How much you will get? 107 by 3.5. 30.79 TR. From option C is your correct answer. It's better to leave this type of question, or if you know any trick, then it's better. Directly you can solve within 1 minute. Next question, if an IC engine consumes fuel at the rate of, so fuel rate given, MF value given, air fuel ratio given is 20, the mass flow rate of exhaust gas in gram per second. So gram per second now we have to calculate. MF is mass of fuel. How much it's given? 1 gram per second. Air fuel ratio, mass of air by mass of fuel equal to 20. So from here MA equal to 20 into mass of fuel 1, 20 gram per second. The mass flow rate of exhaust gas is how much? So exhaust gas mass flow rate is how much? total mass is mf plus ma. How much you will get? 20 plus 21 gram per second. C is your correct answer. The absolute pressure at a depth of 500 centimeter below the surface of a liquid of relative density 0.85 is equal to how much? So absolute pressure value I have to calculate. H equal to 500 centimeter or 5 meter. Relative density of fluid SF equal to 0.85. So from here we can calculate density value. Density of fuel by density of standard fluid or water equal to 0.85. So density of fuel into 10 to the power 3 85 into 10 kg per meter cube, density unit. Then gauge pressure we have to calculate rho GH. Rho value how much? 85 into 10 into G you will take 10. H height is how much? 5. How much you will get? 85 into 5. 405 into 100. 425 into 100 Newton per meter square. All values are in megapascal. Then absolute pressure we have to calculate. P absolute gauge pressure plus atmospheric pressure plus gauge pressure. This one will convert. Options are in megapascal. So divided by 10 to the power 6 divided by 10 to the power 6, 2 0 you remove, 10 to the power 4. So you will get 0.0425 megapascal. So around, no need to calculate also then, because the atmospheric pressure is 1.013. This is in bar. Then bar is 10 to the power 5. Then you will get 0.13. This is in megapascal. Then gauge pressure 0.0425. So 0.1. B is your correct answer. No need to calculate further also. If you want to calculate, you can calculate. You will get megapascal. B is your correct answer. Only thing you have to remember, atmospheric pressure 1.013 bar or 10 to the power 5 Pascal. 1 bar equal to 10 to the power 5 Pascal. Megapascal if you want. Then 10 to the power 6 megapascal. All options are in megapascal, so we have to convert in megapascal. Next question, in Kaplan turbine, the flow velocity. So flow velocity in Kaplan turbine, we know Vf1 is equal to Vf2. You just remember this one. Okay, this one many times asked in different exams. It's constant along the radius, maximum at the midpoint, inversely proportional to radius, directly proportional to radius. A is your correct answer. In Kaplan turbine, the flow velocity Vf1 equal to Vf2 is constant along the radius. A closed container is termed as boiler if its volume exceeds in liter 22.75. B is your correct answer. This one also direct question, many times asked. Morse test is used to find, I think this one asked in OPSC paper, indicated power. Morse test used to find indicated power. Multi-cylinder engine. Next question, the figure shows the PV diagram of an ideal gas. The work done by the gas in the process A, B, C, D, A is how much? So work done, area of this diagram we have to calculate. A, B, C, D, A area you have to calculate. You convert it into two parts. Part 1, then part 2. One more name you give, E here. Then A, B, C, E area you have to calculate. Then triangle area, AED or ADE area you have to calculate. You will get your work done. So, A, B, C, E, work done is how much? AB into or W1, ABCE area is how much? BC is 2P minus P into AB is how much? 2V minus V P into V. This is W1, area of 1. Then W2, how much you will get? Half into base into AE into DE. So AE is how much? 2P minus P into DE is 3V minus 2V PV by 2. So total work done or work done by the gas in the process A, B, C, D, A is how much? W1 plus W2 0.5 D is your correct answer. Steam nozzle question. In a nozzle, steam is flowing. If the back pressure is equal to the critical pressure, the mass flow rate of steam is maximum. This one also regular question. Back pressure is equal to critical pressure. Then mass flow rate of steam is how much? This is maximum. C is your correct answer. For we know for choked flow, your mass flow rate is maximum when your back pressure is equal to critical flow, and flow is called as choked flow. This formula also you have to remember. Sometimes they will ask P2 by P1. Directly this formula in option you will get. So P2 equal to your critical pressure PC, P1 is your inlet pressure. C is your correct answer. Theory of machine question. Mobility of the shown mechanism is how much? The degree of freedom you have to calculate. 3 into L minus 1 minus 2J minus H. Kuchbach equation. Then number of link L is how much? 1, 1, 2, 3, 8 links. L equal to 8. J equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H equal to 0. That's 2 into 10. degree of freedom is 1 or mobility is 1. B is your correct answer. This is the end of part 4. Thank you friends. Thanks for watching my video. Thank you.